No, we're Hydrotech Consultancy, and this is our presentation for our hydrogen plant.
So first of all, we're going to talk about the project background. One of the processes that is popular to produce hydrogen is by steam methane reforming, or SMR, although other methods also exist. One of the major applications of the product, which is hydrogen, it is used in refineries, in which it assists in cracking of hydrocarbons, and in agriculture, in which it is used to produce fertilizers, and also one of the side products, which is carbon dioxide, is used to produce polymers. The typical steam to carbon ratio that we can use is 3, which is between the 2.5 to 5 ratio. And if we talk about the consequence of using other ratios, for a low ratio, it will cause a carbon laydown, and for the high ratio, it will lower the process efficiency by significant amounts.
The team has found that the best location is Hong Kong, China, due to its high developed hydrogen industry. China consumes approximately 25% of the total hydrogen produced worldwide. Additionally, China stood first in 2017, producing 22 tons of hydrogen. About the cost of hydrogen, this can vary widely depending on the process used. Finally, the team would like to recommend the following markets, as these are the main hydrogen consuming industries. These are petroleum refining and ammonia production in the agricultural sector. Also, the company may wish to focus on smaller markets such as fuel cell vehicles or methanol production.
We have decided to improve the production process by redirecting the water separated from the flash drum back into the heat exchanger. This aids the preheating process. The reactor is now insulated with a phenolic foam. Phenolic foam has a characteristic of low thermal conductivity, and this will ensure minimal heat loss from the reform reactor.
And to ensure that all of our equipment is working optimally, we're going to ensure regular maintenance checks by qualified staff, and also have automatic startups of backup pumps in case anything fails, as well as monitoring temperature and pressure of pipes and equipment.
Performing the HAZOP has informed us that many of the safety concerns are related to fire hazards. The gases used are highly flammable and odorless and tasteless. So in the event of the leak, gas detection sensors would be needed to detect them, and are recommended that all the workers carry those. We also recommend fireproof clothing and equipment for all the employees. Special precaution must be given to hydrogen flames, as they are invisible in daylight and produce very little heat, so it's hard to tell when something is caught on fire. As well, hydrogen has a very low ignition energy and a very wide flammability range. The chance of rupture of the pipes is greater due to hydrogen embrittlement, where pipes absorb hydrogen atoms over time, and so our company has researched more resistant stainless steel alloys to be used. Because these gases can be explosive when ignited in confined regions, a blast-proof ventilation system is recommended. The inhalation of toxic substances is also a concern, as carbon monoxide and hydrogen sulfide, if natural gas leaks before the desulfurization unit, can be leaked, and these substances can be lethal in acute concentrations, and as such, respirators are suggested.
We're now going to take a look at the summary. So overall, the key aspects of the project to take away from the poster are that the hydrogen production plant will be in China due to its substantial involvement in the hydrogen industry, as well as the economic benefits that it offers.
With regards to the actual process of hydrogen production, we have deduced that the ideal steam to hydrocarbon ratio in the reformer unit should range from 2.5 to 5.0, and the heat requirement should be approximately 444 megawatt for the process to be successful. Finally, the safety aspect of the project primarily revolve around preventing gas leak from the piping system, as many of the gases involved in this process are very toxic and flammable. And that is all from us. Thank you.